Hello, my friends, and thank you for watching this video lecture. In the previous lecture, I talked about the basics of SQL, and also I show you how to install MS SQL Server. In today's lecture, we are going to learn about DDL and queries in MS SQL Server. So this is the university database that we will work on. So today we are going to define all these tables in SQL. As I told you in the previous lecture, SQL has four main functions: DDL, DML, DCL, and TCL. DDL defines database structure using commands like create table, and we set up our tables, indexes, views, and also we manage access rights. Then for the DML, data manipulation language, it manages data with commands like insert, update, delete, and select to add, modify, remove, and retrieve data. Then we have DCL. This handles security and access control with commands like grant and revoke to assign or remove user permission, and this helps us to ensure data integrity. And the last but not least is transaction control language. TCL manages transactions with commands like commit, rollback, and save point, and these are used to ensure changes are saved or undone correctly. In this way, we can maintain reliability in our databases. So these four functions, DDL, DML, DCL, and TCL, collectively enable comprehensive control of our database structure, data security, and transaction reliability. So the first one is DDL, Data Definition Language. DDL enables defining details about relations like the schema for each relation, the value domain for each attribute, integrity constraints, and also it can covers indices to be maintained for each relation, security and authorization details for each relation, and also the physical storage structure of each relation on disk. So here you can see the domain type in SQL. We have different kind of domain types. For example, char, and this is used for character string. We can define the fixed length like n, maximum characters is 8,000 characters. Then we have varchar n, this is also for character string, and this has a variable length, and we can define n here. Then we have nchar n, this is Unicode character string, and we can go for fixed length of n, and it can have maximum 4,000 characters. Then we have nvarchar, this is a Unicode character string, we can use it for different language. Then we have integer can accept 4-byte integer from -2 billion something to +2 billion something. Then we have a small integer accepts up to 2 bytes, and the range is -32,000 up to 32,000. Then we have big integer for big, this number from minus to positive. Then we have numeric, for example, like for dollar, we can say $100.20, right? It has a fixed point number and precision of these p digits, and d is for decimal. Then we have decimal p and d, this is same as numeric, and fixed point number, precision p, and scale d. Then we have float, real, double precision, date time, bit, binary, and var binary. We will learn all of them one by one in different examples. So in order to create a relation, we need to go for our database. Once we generated our database, then we can generate our tables, right? So I will show you how to do it step by step. So here is the MS SQL Server. And if you want to create a database, simply you right click on databases, new database, and you can select your name of your database, whatever it is, for example, database 1, and you can click on OK here. Already I have made this university database and I want to work with this one. So now I want to create some tables here. So I right click on here, I select new query here. So in here, I can write my queries. So the first table that I'm going to make is classroom table, right? So I start with create. This is the keyword that must be there, and table, and the name of my table is classroom, right? So I want to define a table named classroom in order to store details about physical classroom. So two parentheses, then in here I will start coding. The first attribute in classroom is building, and the type of this attribute is varchar, and I define that the maximum length is 15, and also I decide to be not null. It means it means the user must enter some information for this one. It is required field, and the user who is going to enter information in this table must enter some building for this table. Then we have a room number, and again varchar, and the maximum can be 7. We say room number as varchar, maybe we use some alphabet with room, for example B103, something like this, right? And also this one not. So we created a column room number that stores the room number, and the maximum character is 7, and it cannot be null. Then I go for capacity of each room. So this stores the maximum number of seats, and it can be up to 50 something. So I go for a small int. Then I want to add some constraint here that it should not be negative, right? So we have no negative. It should be greater than 0. And if a user enter negative number for this one, there should be an error. So I ask for check, and in here, capacity should be greater than or equal to 0. Then we need to define primary keys. We can go and define a composite primary key on building. Building and room number can be together. Primary key in order to uniquely identify each classroom. Primary primary key, and we go for building and room number. So we have defined this table, and we select this code, click on execute. So command completed successfully. Do you want to see this table that we have made? So we make a query, select all from classroom, right? You select it and press F5. You can see building, room number, and capacity here. Next, I will go for department table. I want to define a table named department to store information about academic departments. Create table department. And again, the same, we will define the attributes. The first attribute is department name, depth name, and the domain type is varchar, and the maximum length is 20, and it should be not. Then I can go for building, and varchar. This is the second attribute, or you can say second column in this table, and this is used to store the building where department is located. Maximum is 15 characters, but it can be null. It's not that much necessary to know if department is in which building. Next, we go for budget of the department. Budget is decimal 12 and 2. 12 and 2, it means the maximum length is 12 digits, and 2 are the decimal point. And also here we check that it should not be negative. So budget should be always greater than 0. Next, we go for primary key, and in this table, based on our schema for the department name is primary key. So primary key is depth underscore name. Again, we will select it, we will execute. You can see command completed successfully, and the same, select all from department, select it, execute, and you can see department name, building, and budget. Next, we will go for course table, create table course. So we have course ID varchar maximum 8 and not. Then we have title, of course. Again, this is varchar, and the maximum size is like 50, and it should be not now. Then we have department name, and it's also varchar, and the maximum is 20. It can be null. Then we have credits, a small integer, and we check that credits should be greater than 0. Then we need to define primary key. So primary key here is course ID, right? This course table has this department name in course. This department name is the primary key in department table. So we need to connect it, right? That's why in here we write foreign key, and foreign key is department name. And with which table we write references, department table, and where in the department table, the name is the primary key. If the reference department is deleted, we can select the department name to null, right? On delete set null, on update cascade. What happened here? It says if the reference department is deleted, in this table we set this one as null. And in the department table, this has been updated. We will update it accordingly, right? So this is the meaning of these two. So let's execute it. And you can see command completely executed. Then I can write select all from this table course, and you can see course ID, title, department name, and credits. Next, I will go for instructor table. Create table instructor. Then again the same. In here we have ID, or you can say instructor ID. It's varchar 5, for example, and it should be not null. Then we have name as varchar, and the maximum should be 20 and not null. Then we have department name again varchar maximum 20, and it can be null, right? Then salary is decimal of 8 and 2. Maximum length is 8, and 2 of that 8 can be decimal point. And also we can add here check. For example, salary should be greater than like $30,000 because it is yearly. So in this table, we define the instructor ID as the primary key. So primary key in this table is instructor ID, and foreign key. So this instructor table, where is it? It's connected to this department, right? It's connected to department. So I write here foreign key is depth name, and references is department table, and the primary key in department table is depth name, right? Again, the same on delete set null, on update cascade. So here it means if it is deleted in that table, in this table it will be null, and if it has been updated in this department table, in here will be updated as well. All right, so let's execute it. So there is one error here. There is already an object named instructor in this database. It means I already made this table. So in this case, I drop table instructor, right? So I will delete it first, then I will generate another one. All right, then I can say select all from instructor. You can see instructor ID, name, department name, and salary. Next, I want to go for time slot table. So create table time slots, then time slot ID varchar for and not null, then day, right? So in time slot, we have time slot ID, day, start time, and time, right? So for the day, we write day, then char 1, right? And check day should be in, like Monday, Tuesday, Wednesday, Thursday, R for Thursday, F for Friday, S for Saturday, and U for Sunday. Then start time, start time, it's a kind of time, and it should be not null. Then we have end time, it's a kind of time and not null. Then we define primary key. Primary key for this table is time slot ID. Time slot ID. Time slot ID, and we check that start time should be less than end time for valid scheduling. So we check that start time is always less than end time. All right, and also we have to ensure that no two time slots have the same day and start time in order to prevent scheduling conflict. So in here we go for unique and we ask for day and start time. In this way, we prevent conflicts. Very good. Let's execute this one. It's okay. So let's see our table. Select all from this one. Execute. You can see time slot ID, day, start time, and end time. Next, I will go for section table. Create table section. In here we have course ID. Course ID can be varchar 8, and it should be not null. Then I go for section ID, same varchar 8 and not null. Then I can go for semester character 6, and it should be not null. Also, I will check the semester should be in some specific values, right? So check semester in like fall, winter, spring, and summer. Okay. Next, year. The type of year is a small int. It should be not null. And we also check that year should be, for example, greater than 1,800 and year should be less than, for example, 2,100. Then our next one is building. Building should be varchar, and the maximum length is 15. Then the next one is room number. Room number, it should be varchar of 7. And time slot ID should be varchar of 4 with maximum 4. In here we have for the section we have primary keys like course ID, section ID, semester, and year. All together are primary keys. So primary key is course ID, section ID, semester, and year. And this table also is connected to course and classroom. So this table is connected to course and classroom. Let's go for foreign keys. Foreign key, course ID, and references is course, and the key is course ID. Then the same on delete cascade. Whenever it has been deleted, it should be deleted here, and whenever it is updated, it should be updated here as well. Then we have another foreign key here. So foreign, I will copy the same. Foreign key here we have building room number. Reference is classroom, and the attributes are building and room number. And on delete on delete, we set as null. Also, this one no need. Also, this table is connected to TimeSlot as well. You can see here, it's TimeSlot. So we have to define this one as well. So foreign key, TimeSlot ID, TimeSlot ID, and reference is TimeSlot, and the key is TimeSlot ID, and on delete set as null. Great. We did it. All right, let's execute this one. There is an error. So you can see there is a mistake here. There is a mistake here, typing mistake. Great. Then we can go for select star from this one, and you can see we made this table successfully. The next one is teach table. So create table teach instructor ID varchar 5 not null, then course ID varchar 8 not null, section ID varchar 8 not null, semester car 6 not null, year small e not null. Okay, so these are the attributes. Now we go for primary key. So you can see here, teach is here, is connected to instructor, it is connected to section, it is connected to primary key. Here is, what is the primary key in here? You can see primary key all together are primary key, right? All the attributes are primary key. So instructor ID, course ID, section ID, semester, and year, right? Then we can see that this table is connected to instructor and section. All right, so we define foreign key, course ID, section, semester, year, this is connected to references, section, and in here the same. Then we can add, for example, on delete, cascade, and on update also cascade. Right? Then we have also foreign key in this table getting from the instructor table. And in here, it is instructor ID. Instructor ID references is the instructor, and this is connected to instructor ID. And we can add here like undelete cascade. All right, so let's execute this one as well. Great. Teach. Select all from teach. Correct. Then we go for student table, create table student. Then student ID varchar 5 not null. Then name varchar 20 not null. Then department name varchar 20. Then total credit a small int, and by default it can be 0, and also we check that total credit is greater than 0. Primary key here is student ID, and this student is connected to department, so a foreign key here is the department name, and references is the department table, and this is dept underscore name, right? Also on delete, set null, on updates, cascade. Finished. All right, we can execute. All right, it means I already created this student in this database, so I should drop table student, execute. Then again, I will execute this one, and it's fine. Select all from student, run it, student ID, name, department name, and total credit. Next, we will go for text table, create table text. Then in here we have student ID varchar of 5 and null. Then course ID varchar 8 not null. Then section ID varchar 8 not null. Semester char 6 not null. Year small int not null. Grade varchar 2, and we can check here that grade should be in like A plus, A, B plus, B, C plus, C plus, C, D plus, D, and F. Also, you can say it can be null as well, right? So null is also, it's okay, because it's by default, you can change it. The maximum character is 2, because we have A plus. Then in this table, primary key is the all together, right? Student ID, course ID, section ID, and semester, and year. All right. This table is connected with section table and student table. So for the section, foreign key, course ID, section ID, semester ID, and course ID, section ID, semester. This one should be here. Course ID, section ID, semester, and year all together are foreign key, and with references with a section which all together. On delete, cascade, on update, also cascade. Then it is also connected to a student table. So foreign key here is student ID, and references is student with student ID. On delete, cascade. Let's run this one as well. Problem in this one should be on. Okay, successfully. Then let's see the table. Select all from text. Student ID, course ID, section ID, semester year, and grade. The next one is advisor table here. So create table advisor. In here we have student ID varchar 5 not null. Then we have instructor ID varchar also 5. The primary key here it is student ID, and this table is also connected to instructor and student. Foreign key instructor ID, references instructor, and based on instructor ID. Instructor ID on delete set no. We have foreign, and this time student ID, references students, and student ID, and on delete cascade. So let's execute this one as well. Error on delete. Okay, advisor, select all from advisor. Okay, student ID is right. The last one is prerequisite table, this one. So create table prerequisite course ID varchar 8 not no prerequisite ID varchar 8 not null. Then primary key in this table is both course ID and prerequisite ID. This table is connected to course, foreign key, course ID, references, course ID, on delete, cascade, on update, cascade. Let's execute this one. Error is here. Select all from prerequisite. Okay, correct. But if you see here, this prerequisite ID connect also prerequisite ID. This prerequisite ID goes to course ID, because anyway, prerequisite ID is also a course. Then in here, we can add another foreign key as prerequisite ID, references course and course. Okay, so if I drop the table, so the table is still available, I need to drop table prerequisites. Then I will execute this one. Okay, and in here the same. So it's correct. So this is our university database. You can see advisor, classroom, course, department, instructor, prerequisite section, and all are here. And if you click on this university diagram and you ask for new database diagram, then click on yes, and you select all tables, then you can see the university diagram in here. So you can see this is our university diagram. These are all tables that we have generated, and they are connected to each other using the table. Okay, so that's enough for today. In this lecture, we learn how to create tables, connect them together, and show the diagram. Please practice and feel free to ask me your questions by leaving a comment below this video lecture. Thank you, and see you in the next lecture.